Okay, we'll start this with the original. Kind of walk through like we did the first time. Hit the micropython. Go down here to new project. Just pick the first one, ESP32. We don't need anything special. We'll run through the library setup, kind of like things before. So we'll import the machine from machine import pin. That's important for setting up the pins. Then you have to import DHT. I'll explain that in a minute, but that's the sensor we're going to use, and then we'll import time. So some of this will start looking the same as we've done before. We need to define the pin where the dht22 and the LED are connected. And we can do that right now just by adding the LED. We'll add the resistor, and then we'll just look for the dht22. Here we go. Go like this and like this. We'll plug this over here. You've done this one before. But basically, we just go ground on one side. Let's just do the part we know how to do. We'll take the positive side. We'll connect it to the resistor. Plug it in here. And then we'll just pick a pin. I mean, you can really pick any pin that we want. Zoom in a little bit. We'll just pick 5. Seems like a decent one to try. So we'll go with that one. Well, now we need to hook up the dht22. And again, you can click on that little question mark. It'll show you more about it. VCC, which is the voltage, the digital pin, not connected, and the ground pin. So let's hook up the ones we know. We know where this one goes. We'll just hook this to 5 volts for fun. Ground, we know where ground goes. Ground goes here. And this, there's our pins that it recommends, but we'll just pick one that I know how to use. Go over here to 21. Boom. Now we are connected. So magic can happen. We have our ESP32 connected to an LED and a temperature. And what we'll do this time, instead of blinking the LED, is when the temperature gets too hot, we will turn on the LED. And I'll say why that's important, because that sets you up for turning on other things like relays, fans, opening windows, things like that, if you care about those things. So now let's define the pin. DHT pin is going to be machine.pin 21. That's easy enough. DHT sensor. So we need to set up the DHT sensor. So we'll just basically import. When we imported that library, it lets us do this. And then we just kind of do DHT, set a variable for the pin, and it sets it up at the same time. We need a couple of variables to track our values that we read, which are going to be temperature and humidity. That is something that is available from the sensor. If I click up here and show you that real quick, I should have showed you. You get a temperature, which comes out in Celsius, and you get humidity, which comes out in percentage, relative humidity. Everybody cares how humid it is, so we'll go with that. So again, just kind of keep going through. So we have a temperature and a humidity sensor, and we might as well set up the LED. And then there will be LED is equal to pin, which we can do pin here versus machine.pin, because up here I imported machine, which means I get access to all the libraries. And this one I did from machine, import pin. 2 different ways to do the same thing, and now I can say LED equals pin because it already knows what it is. And then so we'll go in here and we'll say the pin was, what do we pick, 5? So we'll put 5, and then we set the mode for the pin will be equal pin dot out. And that is good. Leave this here. And then, we'll do a forever loop just because that's always fun. And in the future, we'll do more logic on instead of just forever pins. Forever, but this was, we'll use this for now. Try. And I'll teach you some cool stuff. Sensor dot measure. So basically, you have to tell it to measure, and then we will be able to get the values out. So now let's use that variable we set above. And we'll say DHT sensor dot temperature, and that's a function. So we have to make sure we put the brackets on the end, open close parentheses, and then humidity, same thing, is going to be DHT underscore sensor, same thing, humidity, boom, now you have both. And the cool thing is you can do temperature, and then we put a bracket like this, and then we can put Celsius, and then we just kind of go close it out, and then dot format, and then temperature, boom, and let's accept OS error as E. Just kind of follow along with me for this one. And then print failed to read from DHT sensor. And then our simulation is probably going to work every time. But if you had it in reality, a lot of things could kind of cause an issue, maybe a different wire, or you have some connection that's messed up. So now we have all this stuff. Let's see if this works. It's always good. Okay to press play. If it fails, that's okay. Boom. He did not like what I did on the syntax on 27. So I must have done. Oh. Trying to figure out what's going on. It's telling me when I press the button that there's an error somewhere. It doesn't really give a good thing, but if I kind of look through what I did, it looks like if we did humidity, let's go kind of up above from where it failed. This looks like a complete statement. Print, oh, here we go. So again, see how that bracket closes that? I didn't close the complete print bracket out. Let's try this again. And then magic should happen. We should get a temperature. Boom, here we go. And you can change the temperature right here, just so you can see it like change. All right, cool. So we can do two things. We can do like this, and then say humidity. Boom, percent. And then format temperature. Okay. Let's make that magic happen. Compile it, see how it goes. There we go, temperature and humidity. So you do the same thing. Change the humidity here. This is great in simulation. Obviously, if it's running a real thing, you'll be good. All right, so great. I got the temperature. Oh, what am I going to do with it? Well, let's do a little bit of logic. So if your temperature is greater than, since it's still in Celsius, we'll just say like what, 30 degrees Celsius. And then we will say, let's do our LED.on. And then we will, since we imported time, we'll say time.sleep. And we'll just do a 0.5. And then I'll always like to do an else, LED.off, time.sleep 0.5. So this will be our first step to reading something in the world, processing it, and doing something back into the world. Boom. So if I make it colder, turn the fan on, for instance, ooh, now we're good. Look at that magic. Pretty awesome. Now, the cool thing is, just following the same pattern we had before, you're like, you know what? I want a fan. So how do I turn on the fan? Well, we don't really have a fan in here, but we do have a relay. So you just take the relay module, and it's pretty simple. Again, it's got the little question mark you can click on. Tells you what voltages you need to worry about. Really, all you need is, so it's got two sides. The left side, which is the one you're going to wire up today, VCC, which is your normal ground voltage, your ground, and then the control signal, which comes from the microcontroller. And on the other side is where you hook up normal voltages to like your fan motor or your light, right? A little bit of fun stuff. So let's just do this. We know where this guy goes. We know he's VCC. So it goes down here to VCC, where we had it before. There we go. And then we'll just take the ground, go like this. Nope, ground there. And then we can pick any pin we want for the relay. Let's just look and kind of see what we have down here. 16 seems good enough. You can pick whatever you want. There's a couple you can't, but we won't worry about those. Just follow me for now, and then we'll work on other stuff later. Boom. Now, what we're going to do is, instead of turning on the LED by itself, we'll turn on this relay. So if the temperature gets to a certain, we're saying now 30 degrees, I want to turn on my fan. This simulates that. So temperature is minus 1.9 degrees. You don't need a fan. But if it gets any hotter than that, boom. Notice the, oh, yeah, my bad. I forgot to do that one thing. This is important. So you can add it all day long. Physically, you have got to tell it what to do. So we'll just do it right here. Fan relay equals pen 16, and we'll say mode equals pen dot out. Now, if temperature is greater than 30, we have to turn the fan relay dot on. Yes, we still do. And then else, same thing, fan relay dot off. Now, it will know what to do with this physical thing that I've connected. So currently I have the temperature at a certain amount, and you'll see this guy turn on here in a second. So let's turn his temperature up. Boom, see? We'll turn it down, turn the fan off, turn the fan on, turn the fan off, turn the fan on, turn the fan off. Great job! All right, now you can expand on this. You can do all sorts of other things, but for now, that is a great thing to get into your mind to allow you to, one, read from the world, operate in the world, do some logic, simple logic, and feel good about yourself. So we'll do more of this again later.